Hi, my name is Nathaniel Davis Perez, and this is my assignment 5. So, real quick, I'm just going to go through the README markdown document. So, I've got my execution, which is launching the leader, then launching the 3 node instances, and then launching the client, and then following the command line interface inputs. So, the purpose of this assignment is to build a simple distributed algorithm that distributes computation across multiple nodes. This includes basic consensus algorithm to verify the results, and it's focused on robustness, cleanliness, and proper documentation. So my protocol for the JSON messages are, here I've got the client requests, which is the client class to the leader class. We've got regular requests, success requests, and error responses. I meant send success responses. We have the node task distribution, which is from the leader class to the nodes class. The consensus check for faulty nodes from leader to the node. Overall workflow and requirements. Quick analysis is that the distributed system demonstrates performance advantages in situations where computational workload is substantial. Parallel processing across nodes consistently outperforms single-threaded computation in scenarios of a larger scale, but its benefits are lost at a smaller scale. Centralized processing is best in scenarios of low system overhead, since communication and JSON responses bring their own delays. The impact of the delays becomes neglected when the overhead outweighs the delays. So that's my README. And I use JSON utils.java and network utils.java to send and receive responses and requests. So real quick, this is my client.java. This is my nodes.java. And my leader.java. And my build me looks like this, with run leader, run node, and run client, and the execution instructions for completion right here. So I'm going to go ahead and show the functionality of the program. So I've got leader, node, 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 and then client. So to show the first demonstration is that the program requires 3 nodes. So for instance, if I start the leader, I can see that leader started on port 8000. Then I start 2 nodes. I can see that the first node connected, and I can see that the second node connected. So normally you would run a third node, but to show that the program doesn't compile without all 3 nodes, I'm going to run it with only 2. So I'm going to run the client real quick. Let's do a test. So 1, 2, 3, 100, and it returns an error, not enough nodes, 3 required. So I've got 1, 2 running right now and the server. So I can see that as soon as I run a third node, you can see that the third node connects. If I run this one more time, you can see that the consensus check failed because I am running a faulty node at the moment. But if I were to turn off the server, turn it back on, relaunch it, I'm going to run the leader. I'm going to run the first two nodes. And then run the third node, just regularly. It's not going to be a faulty node, just to show that it works. Then I run the client. We can see that all three nodes are connected. The client connects. So if I enter 1, 2, 3, the answer should be 6. And we see the total sum is 6, single processing time and distributed processing time across nodes. And if we look on leader.java, we can see 1, 2, 3 list gets passed with appropriate JSON type. And we can see that it passes the consensus check only when all three agree on the result. So, to show that the faulty works, I'm going to go ahead and just run it one more time on faulty. So I'm going to run the leader. Then I'm going to run the node. I can see the first node connected. The second node connected. And then I'm going to run this with a fault. So this should fail the consensus check. So the first node is non-faulty, so just regular normal node. The second one's a normal node. And then the third one is a faulty node. So if I enter 1, 2, 3, again, error, consensus check failed, which is exactly what we want. So yeah, that's it. That's my assignment 5. Thank you.